All right. No daily check because we're right smack in the middle of the section, but we finished off example 3. I want you to do these 2. Okay? Who what? Oh, the mega stapler right there. 3A and B. We did the examples yesterday. We never got to do the practice. Go. Hop right in.
Alright. So you're going to make time.
Next week,
Tuesday. That means you have a lot of options.
Seniors also want to know check out coming up. Mark Green White, Spirit. Next week, you'll vote for some graduation items, senior best in class awards, all kinds of items coming up for you on Moodle. Also, seniors, reminders, meet with me in the theater, 145 on Tuesday, May 9th. Again, make sure you bring your computer. Should not take any more than 15 or 20 minutes on Tuesday, May 9th, 145 in the theater. National Honor Society meeting today during lunch. This is Whitesburg room. National Honor Society members, please check your email for the details about the meeting. Freshmen NWEA testing next Tuesday and Thursday during Spartan time. All freshmen report to your Spartan time teacher, and they will administer the math on Tuesday and the language arts test on Thursday of next week. Just a reminder for all students attending the West River Math Contest. The bus will be leaving at 8 a.m. loading in front of the school and returning at approximately 3. That's on Monday, May 8th. Any questions? See Mr. Spears. And that's the West River Math Contest on Monday. So please stand for the pledge.
United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
No, I'm probably listening like this. Oh, that's either all day. Alright, so then you do the one.
Why don't you guys do this one first?
Yeah, so 8 and 61.
Jimmy has it like this already.
So if you mess up, wait, Samantha, no, Samantha's right. So then you go, and then you gotta go, I don't remember why. There's a certain reason why. You'll find out.
Okay. So you put it in like the arc,
Yeah.
not that. Or I mean, not that,
Well,
but
yeah, I see. And then. And if you get an error, then more than likely. So then this one I know.
oh, you sure? Okay.
Works
B is
smarter.
not gonna have a lot of room.
So then, well, no, because there's no triangles. You don't have to. So now we go to B.
Darn it, Frank. Okay, I usually set mine up like this. So that I have the angle side set up with that left corner. That way I'm just kind of doing the same thing every time. Do you have a control pair to get started? Yeah, I do. So, what do I find next? Angle A, angle C, or little c? Okay, I should be aiming for angle A because it's across from the other side that I have. So we set up law of sines. Remember, I ain't going to be doing this full write-up every time. Because when you multiply what lines up and divide by what doesn't, there we go. 12 times sine of 61 divided by 8 equals the sine of A. It's going to give me, theoretically, some little decimal between -1 and 1 because I have to arc sine that value. So I would just say the measure of angle A is arc sine of 12 sine of 61 over 8. And I already know that I'm screwed because the sine of 61 is square root of 3 over 2. Or sorry, the sine of 60 is square root of 3 over 2. And I know this is going to be really, really close. So this is about 0.85. Times 3/2 is probably bigger than 1. So we get our calculatron out. We make sure we're in degrees because we're trying to find a degree angle. I go arc sine of, make fraction, say 12 sine of 61, bloop, over 8, bloop, and it tells me no, because that is a value greater than 1. What they're saying is that this triangle, if I were to make it more accurately, looks like this. It just kind of dangles there. Like it's never actually going to hit the other side. So, no triangle. Contestant 2, how many of you figured out what it is and then found things the correct way? See, if this is a 30-degree angle and this is 13 and this is 26, did anyone notice the ratio there? It's a 30-degree angle, and going from one side to the other is a 2-to-1 ratio. So, if I set up my law of sines, the sine of 30 over 13 is sine of C over 26. Multiply the two that line up, divide by the one that doesn't. We get measure of angle C is arc sine of 26 sine of 30 over 13, because I'm trying to find an angle. But I know the sine of 30 is 1/2. 1/2 by 26 is 13. 13 over 13 is 1. Arc sine of 1 is 90. Remember what I said, that these might have one triangle, two triangles, no triangles. If you have angle side side and you are given one acute angle, you have the possibility of getting a right triangle. So now that I know it's a 90-degree angle and a 30, I know this is 60, use your ratios to finish it off. Don't write this as a decimal. Now that you know it's a 30, 60, 90 triangle, how do you go from short side to long side? Square root thing, multiply by square root of 3. I wrote, I just like did a double take there, like, wait a second. I said 30, 60, 90, and then just wrote a 36. How close are you? Okay, we got some breathing room. We were up 4 times last night. Midnight, 1:30, 2:30. Been up since 4:15. So, yeah. So I find angles with arcsine. What we had said yesterday is that the problem with arcsine is regular old sine of an angle gets me x. I put in an angle, I get out a ratio, right? So when I switch over to arcsine, I'm putting in a ratio, I'm getting out an angle. I have to understand that my domain, those ratios can only be -1 to 1. And my output, my range, can only be -pi/2 to pi/2. Beginning of the semester, we talked about reasonable domain. Remember doing, it'd be a polynomial function or something like that, and it'd say, tell me a reasonable domain for this, even though the domain was all real numbers. Well, the domain was something like 0 to the capacity of the factory. Or it was from 0 to how many seats are in the stadium. I had to have something reasonable. We're about to start talking about triangles. If I'm going to do arcsine of a thing, reasonable says that I'm actually going to be putting in 0 to 1, and I'm going to get angles from 0 to pi/2. And that's a problem because that's 0 to 90 degrees. And you can have triangles with angles bigger than 90 degrees. So we did the it's one triangle and it's two and it's no triangles thing. Next example is 2 triangles, and it's very simple. I'm going to set up a triangle like we were just doing, and I'm going to go find this angle. What happens if they tell me that this angle is 60? It's only giving me values from 0 to 90. What else has the exact same sine value as 60? That is a possible angle inside a triangle. 120, because they have the same reference angle. But it's never going to tell me 120 because it's over in this quadrant, and that's illegal. So I'm going to have to go make its evil twin. I'm going to have to go make the other triangle. That my calculator will never tell me. But I got to be smarter than the calculator because I know that this was a possibility. Okay? And then I would just finish off both triangles. So, The next example, the reason that there is no angle side side in geometry. Start by setting up a triangle. I would make it an acute triangle. We'll give it a little bit of room. We have angle A is 43 degrees. Across from it is 25, little a. I like, this is my personal preference, doesn't have to be how you set them up. The angle, the side, and then I hinge this back and forth. I'm going to put the 28 here with B here, angle C here, little c there. So I set up my triangle and I just start to solve it like normal. Do I got a control pair? Yeah, I do. I can use that to find angle B or C. B, since that's the opposite side that I have across from it. If you want to write another calculator shortcut, remember how I said if you're trying to find side A, you always had your control pair right here, and then used sine of A with it? Well, if I'm trying to find angle A, it's the same business, I'm just flipping everything, because now I'm finding the angle instead of the side length. The measure of angle A is going to be arc sine of, you're going to have sine of B up here, little b down here, and then I'm going to have side length A up top. Okay? They're always going to set up like that. Go back and look at the previous example. When you dumped it into the calculator, wasn't it always number times sine over value? Like side length times sine of angle over side length. They're always going to set up like that. Do it one last time to prove it. The sine of 43 over 25 is sine of B over 28. If we multiply the two that line up and divide by the one that doesn't, I'll get the measure of angle B is arc sine to find angle 28 sine of 43 over 25. You see again that control pair. That control pair. Okay? They're always going to set up like that. That's just how a proportion works. Okay? So go press the monkey buttons. What do we get? Angle B is about how much? Survey says? Okay. So here's the issue. 49.804 is the angle in quadrant 1 that has this sine ratio. But there's another angle over in quadrant 2 that has that exact same sine value, and my calculator won't tell me because it's not a part of the legal range. So we need to, easy fix. Come on, Frank. All right, what was that? Sine of 25. Come on, slow Frank. 43. I hate you. I take that back. Like, it takes a lot of effort to hate. Someone's got to be worth it. If this is one of the angles, then nicely 180 minus that is the other angle, right? About 50 and about 130, they've got the same reference angle. So I'm going to come over here and make the evil doppelganger that has A is 43 across from 25, B across from 28, angle C little c. If I found this angle, I have to know that his evil twin 130 point, what's that, 196? Also exists. Okay, and it's just 180 minus that angle. Okay, cool. You've got two triangles with a control pair. You found both the quadrant 1 and quadrant 2 possible angles. Now you just finish them both off. Yes, ma'am.
So, how are we going like the way you did do on the other triangles?
Remember that when you have that acute angle, if you have a acute angle side, you in trouble. That means there's possibility of a right triangle, no triangles, or two triangles. Because if I have an acute angle and an acute angle, isn't it possible to still have an obtuse angle? So that tells me that there was another possibility. Now, there are instances where maybe I do this and this angle is a little bit too big. Let's say this comes out as like, say it comes out as 30. No, 20. What's 180 minus 20? I would come over here and I would write 160. But 160 plus 43 is too far past 180. The second triangle wasn't possible because of the size of this angle. So I'm always going to try to find this angle and its evil twin and then solve the triangles. It's possible that I will try to solve this triangle and say, oh wait, that's not possible. So I just X this out and there's only one triangle possible. That's why I said the acute angle side makes everything weird. And that's why we didn't have that congruence theorem or that similarity theorem in geometry. Because it might be one, it might be two, it might be none. Who knows? I just have to run it through and check. Now, right before the previous example, they had all the conditions. You would do Pythagorean theorem to find the missing side. That's the shortest length it could be, and then you'd compare if A is less than B and B is greater than C kind of crap. Like, there's conditions for when this happens. I'm saying just try it, and if it doesn't work, cross it out. Okay? It's simpler. So, I'm not done yet because I have an angle, I can go find angle C. I have an angle, I can go find angle C. This is where you're going to want to use that calculator and what is in the memory of the calculator very well. Now, the last thing that I have in my calculator is this 130 and a change, so all of this calculation is currently in the memory. I want to keep working over here for now because everything is in the memory of my calculator. I'm going to have perfect answers. So if I do 180 minus 43 plus my answer, right? That's Measure of angle C is 180 minus 43 plus B. I'm going to go get little c, and it is little indeed. Itty bitty living space. So 6.804 degrees. Have I solved the second triangle yet? Now I got to go find little c. So to find little c, I've got my control pair. I now have the angle across from C. I can set up law of sines. Okay, sine of 43 over 25 is sine of angle C that I just found over little c. Good thing I have an answer in my calculator now, right? Use the value in the calculator so that you always have the perfect value. Multiply the two that line up, divide by the one that doesn't, and I'll get little c is 25 sine of that answer over sine of 43. Use that answer button. Keep everything in chain. 25 sine of my answer over sine of 43. Boop. And it should be small, because look at the angle it's across from. Okay? And I'll get little bitty c is about 4.343. What? Oh, yeah. Now, when I said that I have my 3 decimal place rule, I want you to look along the train here, and what if I had done, if I had cut this off at 804, then this would have been 196, this would have been 804. When I did this problem back here, 25 sine of only that angle, 6.804 over sine of 43. Look at how close it still is compared to the perfect answer, right? So if you don't like using all of these signs and numbers all over the place, then just use the decimal value out to 3 places. I'm telling you, your round-off error will not be that big. Okay, that's where this rule came from. All right, so I found my missing side, my missing angle, my missing angle. I found my missing angle. I need to come all the way back here and find C. You tell me. How do I find the original C? Look at what measurements we have. Right? I've got 2 angles. Do 180 minus the other angles. Measure angle C is 180 minus 43 plus angle B. Except I'm talking about this B. So I can go back to my calculator. Remember, I have that calculation way up here. I can go back to perfect by saying 180 minus 43 plus. I can go all the way back to that calculation. This is a nice thing about right view calculators. And I can go back to the original calculation to slam the whole works in there. And then I'll get perfect. Okay. Now you don't have to do that. You can just put the 49 and change in there. That's fine. I'm just saying, some of us get kind of prickly about details and needing to be perfect. Throwing absolutely no shade at anyone. So 87.196. Have I solved the triangle yet? Go find little c again. And yet again, use your control pair. Little c is going to be 25 over sine of 43. Then the angle that I just said, sine of that answer that's now in the memory of my calculator so that I am perfect. 25 sine of answer divided by, already forgot it, sine of 43, there it is. $36 and change. Now this, remember, I just drew this triangle to wrap my head around it. Turns out that I didn't draw it very proportionally, right? The top angle is supposed to be almost 90. I drew it more like this. That's okay. We're just using it as a guide for our work. So 36 and change. Y'all, these are very involved problems. Lots and lots and lots and lots of steps. With two different triangles. Okay? Now please tell me that you were shown this in geometry. Okay. Maybe shown that this is a thing that can happen, but it wasn't really one of the ones you practiced. Okay? So, I'm going to give you kind of a framework here. You're going to have triangle 1. Again, the sides are all arbitrary. The angles are all arbitrary. Don't worry about them. And triangle 2. To draw who? Well, I mean, your original could have been like this, but then maybe it's angle C that ends up weird instead. So it's like, yeah, like that. Yeah. Maybe it's more like that. Maybe this is the one that ends up obtuse. I've just always done it with the base angle because otherwise you got to kind of go cross-eyed to figure out what it is every time. Okay. You will start with a control pair. Oh, it's up to you. I'm going to say you're going to go do arc sine to find measure of angle B. (180) minus that to go say the measure of angle B, we'll call it B prime, is opposite. Okay, whatever its supplement is. Once you do that, it's just two different triangles of the same type that we were dealing with yesterday. You're going to subtract from 180 to find your missing angles. So measure of angle C is going to be 180 minus A plus B. Oops. There you go, close enough. And then finally you would go find your little c's. By doing little c is, you'd have your control pair, again, A sine of A sine of C. A sine of A sine of C prime. Here, let's put a prime there. Okay, they're always going to set up like that. Every time. You try law of sines, you get angle. Rut-row raggy, I have two acute angles. That means it could have also been a obtuse angle. So you make your second triangle and then finish them both off. Believe me, law of cosines is so much easier than this. The reason is, law of sines, you're using arc sine. Arc sine has quadrants 1 and 4 as possibilities, but the angles could have been in 1 and 2. So we have to jump through all of these mental gymnastic hoops. Where's arc cosine? It's already in 1 and 2. Arc cosine likes big butts and it don't lie. Law of cosines will happily give you acute and obtuse angles every time, and it don't care. It will never end up weird. It is just formula plug and chug. Okay? Yes, ma'am.
Where did we
Get what?
the 13?
It's a B.
Oh, I'm so dumb.
No, you're not.
I'm really smart, really smart, I'm really smart.
You shouldn't default to saying that all the time. It's okay to have mistakes or miscommunications. I mean, I write all of my B's with a little bit of a gap in between them. That's perfectly valid to say, dude, fix your B's. Okay. Are we okay to try one or see it again? Democracy.
Are you crying?
Okay. All right. Okay, I'm just going to draw both right now because that's what we're practicing. It will have two triangles. Silly goose. In color-coded glory. That's a setup. That's where everything's going to go. Yeah.
Okay, so I'm confused. So up here, the 28 would go first. Why down here would be the 8? It was 20. Does that make sense? Wouldn't 10 go before? Or did I do that?
This would be 25. Finding angle B. Okay, your control pair will always be opposite.
Okay.
So,
Because that's the ratio. right?
Yeah.
So down here, since your ratio is sine of 38 and 8, the 8 goes down here, the 10 goes up front.
Okay, so is yours backwards then?
Oh, sorry, I just never wrote my things here. That's going to be 8 sine of 38. Oh, no, backwards.
I just don't understand what we're done.
And 10. There we go.
Wait, what? Oh, I need to slide.
Sorry, I just never wrote the first one.
I also have a question.
Okay, what are we trying to find?
This C.
That C?
Yeah. I figured out what I did.
Arc sine of. Okay, so that guy's good. So that guy's good. So that angle's good.
Wait, do I do that? I don't know what I did.
So now you're trying to find little one?
Yeah.
Eight sine answer over sine 38. I got 2 and change. I don't know what happened here.
Well, right there, I just forgot to put the sign. But I don't know.
Oh, okay. So right up here, yes. But now, when you do this, it's going to use this answer.
Okay.
It always uses the most recent answer.
That's what I.
Yes, ma'am.
When do I stop?
When you have found all of the measurements,
But
all
I do
angles
that,
and all
right?
sides.
I have like the angle B and then it's
Mm-hmm.
that and then angle C and it's opposite.
Okay,
Is that
so
what
it looks like you found both of the angle B's, both of the angle C's. Now got to find both of the little side C's.
What? Both the little side C's?
Mm-hmm.
How do I do that?
You have to set up your law of sines again. Because now you have the angle above it.
Okay.
So you can do sine of 38 over 8 is sine of whatever that was over little c.
Oh, so I said the side. Okay. I don't want to count that.
Do we use? Wait. Oh, that seems like a lot of stuff to write down. So I have to find both. Oh.
Very first thing you do. Okay? Very first thing you do, you find whatever that missing angle is in your very first triangle, because you have one control pair. You're ready to do law of sines. You do arc sine of 10 sine 38 over 8, because control pair, find B. And you're going to get a boot, how much? First angle B. Confirm? Okay. So now I'm going to use that angle in 2 spots. I'm going to use it to go find my evil twin triangle. I can also use it up here to find my missing angle in this triangle. So 50.316 goes here. 50.316 goes here. And I'm telling you, if you just write that decimal value and work with that, you're going to be very, very close. You don't have to use the answer button in the calculator. I just really, really like doing that because now I have the perfect answer. Yours will maybe be a thousandth or two off at the very end. It's not a big deal. I'm not taking points off for that. Okay? So, over here, 180 minus that would be 30.29 and change. 29.684, right? Because 80 minus 50 is 30, minus a little bit more. Oh, sorry, it's never wrote my one. 129.684. Yeah. We're kind of off the map there, but you get the idea. And then again, and again, and again. 129.684. So it's 50 and change minus 38 and change. What's this, 12 and stuff? Okay. And this guy, 88, 90, 91 and something? And then, if I have those, that C can now come down here. That C can now come down here to go find your little c's. You said 136. You said 136. Well, you probably said 316 and exhaustion. It's a real thing right now. 12 point, you said 316? Okay. Oh yeah, it should be because they always match. All right. Then at the very, very end, little c. It's across from 91. It better be the biggest one there. It's got to be bigger than 10. And it's the smallest one, so it better be smaller than 8. Okay. Y'all, these are big. They're involved. There's a lot of stuff there. Okay, the ambiguous case of law of sines. It's got a lot of stuff going on. You're going to find 6 answers, and that involves 6 different pieces of calculation. Expect that when it comes time for your quiz tomorrow, you got one of these on there, but it's going to be worth like 10 points. Okay, it's got a lot of junk going on. Now, here's the nice part. When we go try this again, oh yeah. Boop. You get out of there. You get out of there, you get out of there, you get out of there. Boop. You can set it up the exact same way. It's just now This ain't 38 anymore. It's not 10, it's not 8. You just swap those numbers out and go again. Do you see how this can just be algorithmic? Like you could just set up a formula chain for this. I know this is 65. This is 55, 57. So I can set up my initial one of 55 sine 65, 57. Whoa, bad solving. 57 sine 65 over 55. There we go. 65, 55, 57. Dang, round 2. But what happens when I take away the scaffold? Can you do it? And that's why we have notes and why I say everything should be open notes, open book, open everything. That's how a real functional adult works. We look things up. Okay? Said that unit circle quiz is the only thing I do in all of my math classes where I don't have open notes. You can have zeros. Hearing a lot of good conversations, like double checking our stuff. Which triangle I go to? No, do this one first. It's easier if I go here first. Like, hearing a lot of good stuff. Mm-hmm. There. That's what she boils down to. And I know we got a couple of very algorithmic thinkers in here, where some of us are going to see, oh wait, it just does this every time. I could just like fill in the blank, right? And that is very true. You support yourself however you want to. If you understand the underlying concept, then what you do after that is all on you. So, start with I go find the first angle B, arc sine of stuff, and I get how much? See if we're on. Okay, which I'm going to use to find angle C in the first triangle and subtract from 180 to go find angle B in my second triangle. Okay, let's just finish off this guy while we're here. If I do 65 plus 70-ish, subtract from 180, I'll get about how much? And then I jam that in to go find little c, just like we were doing at the beginning. We go find little c, about how much? Okay, over on the other one, if I took 180 minus that almost 70-ish, we'll get 110 point. And then we'll subtract that and 65 from 180 to go find my other angle C, the evil angle C. Getting, oh boy, 4 point. Woo! Itty bitty living space. Jam that in to find itty bitty C, and itty bitty indeed. How itty bitty? Just 2, 1? Okay. So I would be looking for, come test time, each of those would be worth 1. $180 minus the stuff to find your third angle be worth 1. Understanding that it's 180 minus your first angle to find the other. And then I'd probably be doing the setup for little c's and the setup for your initial angle. Okay? It's usually how we look at them. There's a lot of meat and potatoes there. We okay with it? Like, can we do it? Not do we like it, can we do it? Do we understand where it comes from? Okay? Yes, there's a lot of stuff going on there. I ain't gonna try to sugarcoat that. There's a crap ton of stuff going on there. So, to save you a little bit of mental space, a little bit of mental RAM, substitute, solve. Just like we were doing with the law of science. Okay? So that's where it comes from. What we need to know is that they give us 3 different versions of it here. I'm saying that you don't need 3 versions because A, B, and C are arbitrarily chosen in terms of what the angles and the sides are named. Those vertices can be named whatever I want. The core of the idea is whatever, it's not really the control pair, but whatever the thing is you're trying to find. You're either going to be trying to find angle A or side A. The B and C on either side of them don't particularly matter because in the formula, I'm going to be adding and multiplying them, and both of those operations are commutative. Okay? So I'm going to have A is A equals squared minus B squared C squared 2 BC cosine of A. Okay? But do you see how I'm taking B squared plus C squared? B times C. Those are commutative operations. So which one you call B and C doesn't matter. Like, are you really going to freak out and not be able to use the formula if I gave you a triangle that's this instead? Oh no, there's no ways! How do I solve it? Right? If I knew that, say, this was 5 and this was 7 and this was 38, well, this is the thing I'm trying to find. I put 38 in here, 5 and 7 in there. Okay? So just A is whatever you're trying to find. Yes, sir. Oh, sorry, I'm thinking, no, you rightly called that one out because I'm already thinking of the formula shortcuts. Where's black? I'll be honest, you had me earlier. I figured today was going to be bad. Yeah. Now, I can, you know what, you do have blank space there. I want you to do 2 different things for me. make your own calculator shortcuts. You know how to solve algebraic equations. If you are given a squared is b squared plus c squared minus 2bc cosine of a, I want you to solve for a. If we have a squared is b squared minus c squared plus minus 2bc cosine of a, I want you to solve for angle A. Get little a by itself. Use algebra. Get big A by itself. Use algebra. I think even if we're completely mentally fried, we can probably handle the first one. That's one of the fastest calculator plug and chug shortcuts in all of geometry. Yeah, it's just, I want A, angle A. By the end of it, by the end of this, you should have the measure of angle A equals. So I don't know how big you write. Now, yes, I think everyone already got that one. If I'm trying to find side A, it's just b squared c squared minus 2bc cosine of angle A square root. Are they products? Are they factors? How many of us got caught in that trap of trying to call that 3x? All the way back to the beginning of the year. How many of us tried saying, well, the square root of that is 3 and the square root of that is x? It's a sum. You can't take them out of radical town if it's a sum or a difference. Only factors can come out of a radical. This says plus, this says minus. No, you can't. Okay? So finding a side length is real easy. It's just square root of all of it. But can you get angle A by itself? Hint, hint, if we're trying to find an angle, we can't use regular cosine. Inverse cosine, yes. Oh, that gets you the cosine of A. That's going to get you some itty bitty decimal in between -1 and 1. To finish it off, we have to arc cosine. I have to arc cosine this and arc cosine this for that to cancel. Okay. The measure of angle A. is the arc cosine of a squared minus b squared minus c squared all over negative 2bc schwamp. Okay, law of cosines goes so much faster because it's just calculator, plug and chug. You really should have a right view calculator to help you through this. Those are the ones with a fraction on there, and you can type it exactly the way you wrote it. Because if you don't, if you got an old school calculator where everything's in one big line, you're going to have to go parenthesis bonkers on it. All right. Hockey player attempts a shot 20 feet away from the left goal post, 24 feet from the right post. Regulation goal is 6 feet wide. What is the shot angle? Oh, we have to do this. Hold on. We can go find angle A. So, I'm trying to find this is the thing I'm trying to find, right? So I will treat them as A's. If am I trying to find an angle, or am I trying to find a side length? So I could go the entire formula and solve. I could say 6 squared is 20 squared plus 24 squared minus 2 by 20 by 24 cosine of A. What is 20 squared? What's 20 squared? 400. What's 24 squared? 576, says thou with calculator. 400 plus 576 is 976. 36 minus 976 is negative 940. Is 24 by 2 is 480. 480 by 2 is negative 960. Cosine of A. Eh? No. They're Canadians. They like hockey there, hey. Well, you got to be careful about, I will see a lot of kids do this. They'll say 400 plus 576 minus 960 cosine of A. I'll see kids try to say 976 minus 960, and then they'll write 16 cosine of A. This is smashed up on cosine of A. It's a coefficient of it. But I'll still see kids do it all the way up into PreCalc. Okay? Be careful. Whoop. So you divide. You're going to get some little fraction. Divide by 960, 94 over 96. So what's that? 75, 45, 47 over 48? Yeah. 47, 48 is the cosine of A. So if I want to find angle A, I do the arc cosine of that, right? Well, instead of doing all of the process of solving, instead of reinventing the wheel every time, how about I just do arc cosine of A squared minus B squared minus C squared over negative 2BC. Right? Just jam the numbers in. We already made a formula for ourselves. I'm going to put 6 here. 20 and 20 will go here. 24 and 24 will go here. Or vice versa, because it doesn't matter. In fact, I think I wrote those backwards. Yeah. But because they're multiplied and added, it doesn't matter. And we should get Measure of angle A is about how much? Oh no! All right. A, are we all in degrees? Okay. So we'll do arc cosine, make fraction, make fraction. And we will have 6 squared minus 20 squared minus 24 squared over negative 2 by 20 by 24.
Okay, but isn't the end with the fraction?
Mm-hmm.
Oh, yeah.
I think I just.
You did arc sine.
Well, my negatives are like all over the place. I've got like negative a squared plus b squared plus c squared.
I think Sammy got it right.
So it's just the negative square.
Yeah, you just swap the negatives. Okay. So, do same thing. This time they want us to find, what is it, the angle from the camp to the 2 trails. So, what is your A's? What is your B's and your C's? What? What?
What? I do not.
Well, that explains our night. Baby bear puked twice. Nice and easy. You just label where stuff is. Formula plug and chug. 1.5 with 2, 2, 1, 1. Okay. It's heron, not heroin. How about how much? 46 and change? Okay. Okay. So all of this law of sines and cosine stuff should be review is heading towards, can you solve the triangle? It's not a right triangle. I'm going to give you 3 pieces of information, who knows what, and say solve. We were just given side, side, side. Notice we had all 3 sides. Now we have side, angle, side. First thing you identify is, do I have a control pair to start law of sines? So law of cosines it is. You say, that's the thing I'm trying to find, so I treat that like an A in the formula. I treat the other 2 like a B and C in the formula. Whether they're actually A, B, or C doesn't matter. They're arbitrary. They're just labels. And we have a handy-dandy formula for this already that was just the square root of all that junk. And we go, you plug in everything you know, hit the button on the calculator. You got a 5 and an 8, a 5 and an 8, cosine of the angle, 65. So cosine 65 is in 5, 1/2, 1/2, 2, is in 5, 40, 40, 25, 64, 25, 64, 85, 89. 89 minus 40, 49, so that's 7-ish. Now, I only found one thing. It says solve the triangle. You got to find them all. What is still missing? 2 angles. Don't I have a control pair now? Now that I have the control pair, I'm allowed to do law of sines to find one of my missing angles. Now that I have all 3 sides, I could also do law of cosines to find one of my angles. So you get your choice, and it does actually matter. Because what if angle B was actually supposed to be obtuse? Right? It's the biggest angle. So if I did the law of sines to find angle B, knowing that it's the biggest angle, and it tells me an acute angle, is it really an acute angle? What if it told me 87, but it was actually supposed to be 93? So here's the note that you should write to yourself is, if you're going to switch to law of sines, just find the smallest one first. No, just do the small one first. Because then you subtract from 180 and it'll give you the big angle. Okay? If you're going to switch to law of sines, find the smallest one first. If you're going to stick with law of cosines, it don't care. Law of cosines likes big booties. It likes obtuse angles. It'll give you that just fine. So if I was going to switch to law of sines, I would say angle A first. Arcsine of, there's my control pair, and find that. Okay, from 5. Or I could go to law of cosines instead. Say measure of angle B is arc cosine of. Across from it is the 8, so I treat that as my A value. Minus 5 squared minus 7.429 squared all over negative 2 by 5 by 7.429. And when I'm doing this, I will absolutely be using the answer button, because that will have the most accurate answer. So whether you want to switch to law of sines or stick with law of cosines now, I don't care. You do what you're going to do. I actually write both next to all of them on my answer keys. Just in case. But you don't have to do both of these. Because I already got one angle is 65. If I go find either angle A or B now, I can just subtract from 180 to find the third angle. Okay? So, does anyone got an A for me? Ooh. How votes the village? Okay. And angle B should be the biggest one. It's got to be bigger than 65. You're saying it so quiet. 115. Oh no, we can't just straight up subtract this one from 180 because we also have to include this guy. Maybe 115? Oh, missed a squared right there. That's it.
Isaiah Leho, please come to the office. Isaiah Leho, please come to the office.
Oh, that's problematic. That early release yesterday cost us.